Good morning, everyone. This is one more session with respect to Linux system programming. In this session, we are going to discuss a little bit more about the concept called thread concept. Before starting with the today's session, if my voice is clear as well as able to see the screen properly, please type 1 in the chat box. If my voice is clear as well as able to see the screen properly, please type 1 in the chat box. Okay, thank you very much. If you're able to recollect what is the discussion happened in the last session, will you agree? In the last session, we started thinking about a concept called threads. Thread is nothing but in a big process, a small processes which are independently executes. Again, thread is nothing but a small process in a big process. Now tell me, in this big process, how many threads are there here in this example? Tell me, in this big process, one process, how many threads I represented here? How many threads I represented here? How many threads I represented here? Can I say 4 threads? Every thread, suppose in all these 4 threads, if I write while one, in this first thread while one, in this second thread while one, in this third thread while one, in this fourth thread while one, can I say all these threads while ones will execute? Will you agree? All these threads which are present in a single process, will execute concurrently. Hmm? Now one more thing. Yesterday we are trying to understand the difference between the process and thread. Process is nothing but the program which is loaded into the RAM for execution. Thread is nothing but a small process in a big process. One difference we observed, if two processes wants to communicate between each other, we need to take the help of, if two processes wants to communicate between each other, we need to take the help of IPC mechanisms. If two threads which are present in a single process, if multiple threads which are present in a single process, if they want to communicate, it is just a matter of putting the data into global array. Again, if multiple threads wants to communicate between each other which are present in a single process, there are few common things are present to these threads which are present in a single process. Now can I say all these threads code section is common, data section is common. Whatever the 8 MB of a stack is there, that 8 MB of a stack is shared between these threads. Whatever the 8 MB of a stack is there, that 8 MB of a stack is shared between these threads. All of you are getting this point. Observe here. Observe this scenario. In this scenario, how many threads are represented here? Just give me 1 minute of time. In this scenario, in this diagram, how many threads are there? How many threads are there? 3 threads. My question is, for every thread, is a separate code section is there or is it a common? For every thread, is it a separate code section is there or is it a common? Can I say it is a common? For every thread, separate data section is there or a common? Can I say all the threads will share the common data section? Number of files, how many files we open it, that is also common. But all of you are observing stack is different. Now my question is, for this 8 MB, for this 8 MB, for this 8 MB is allocated, or that 8 MB which is allocated to this process is shared. My question is, for first thread 8 MB separate stack, for second thread 8 MB separate stack, for third thread 8 MB separate stack is allocated, or whatever total process, for total process whatever the memory is allocated, that is get shared. Answer is, for total process whatever the memory is allocated, that is gets divided. Now can I say thread 1 is having a separate stack in that 8 MB, thread 2 is having a separate stack in that 8 MB, thread 3 is having a separate stack in that 8 MB. And also I told you, very important point, the context switch between the processes, the context switching between the processes and the context switch between the threads which are present in a single process, which is faster. The context switch between the threads and the context switch between the processes, which is faster. Can I say between the threads is faster? Can anybody tell me what is the reason? If two processes context switch is going on, if context switch is going on between two processes, if context switch is going on between two processes, so then what happens is total PCB should be loaded and unloaded. Total members of PCB should be loaded and unloaded. But if the context switch is going on between the threads which are present in a single process, there are few properties, there are few parameters, there are few members of the PCB is common between these two. So those common members no need to be loaded and unloaded when the thread context switch is going on. So in this way, the time taken to do the context switching between the threads is becomes faster, whereas the time taken to do the context switch between the processes compared to between the processes. So that is one thing. Yesterday we are trying to understand, in your mobile there are so many applications are there. Every application when you start running, that becomes every application when you start running, that becomes a process. In that process there may be a multiple processes. In that process there may be a multiple lightweight processes. Will you agree? This is one application which I am using. This is one process, and I can press this plus button, I can open one more window. I can press plus button, I can open one more window. So process is same, one process, but three small processes are running there. Are you forgetting the point? Such type of things we are trying to understand. Now next we started thinking about how to create a process. All of you observe, yesterday we started writing a code, very basic code yesterday we written, how to create a thread. And I told you, there are few functions are available. Now what is this? What is this information? Can you tell me? These are common things, common members of the PCB. Now can you tell me, for every thread, what it is created? Can I say TCB is created? Thread control block. In the thread control block, which is not a common, that members will be there. In a TCB, in a thread control block, which is not common members, that will be present in that TCB. That will be present in that TCB. Now, will you agree? For every thread, there is no separate PID. Again, for every thread, there is no separate PID. But for every thread, a separate TID will be there, thread ID. Again, for every thread, there is no separate PID which are present in a single process. But for every thread, separate thread ID will be there. What are these things? Can you tell me? Can you tell me what are these things? These are common things or not common things? These are common members or non-common members? These are common members or not common members? Not common. Now, can you tell me when the context switch between the threads are happening, only these members of the PCB means this is a TCB. Can I say this is the PCB? In that a small portion is called as a TCB. So there are two threads are there. When the context switch between the two threads are happening, only this TCB should be loaded and unloaded, not the entire PCB. In this way, the context switch between the threads are fast. In this way, we are saying the context switch between the threads are faster. Will you agree? Yesterday, we started thinking about what are the functions involved here. Can you tell me in this how many functions are present? How many functions are present in this material? Will you agree? 10 functions. What is the first function? What is the name of the first function? pthread underscore create. For what purpose? To create a new thread. Second function, pthread underscore exit. Name itself tells you something. What is the purpose of this second function? Terminates the calling thread. Pthread underscore exit is used to terminate the calling thread. Yesterday we used this function, right? Pthread underscore self. For what purpose? pthread underscore self. For what purpose? pthread underscore self. For what purpose? To get thread ID. To get pthread underscore self is to get ID of that particular thread ID. And pthread underscore join, we'll see what is the use of pthread underscore join. Pthread underscore detach, for detaching from the main thread. Independent of the main thread, this subthread will execute if you detach it. I told you yesterday one important point. With respect to process management, when we use a fork system call to create a process, the relation between the main process and the process who, because the fork is created, that is called parent and child relation. But in this thread terminology, it is called as, suppose one thread, suppose, will you agree main is a thread? Main is a thread. If in a main function, if we are calling in a main function, if we are calling pthread underscore create function, can I say a subthread is created? Again, in a main function, if we call pthread underscore create function, a subthread is created. The what is the relation between this main and this thread? Not a parent and child relation. Subthreads. Yes or no? Please reply it. And pthread underscore mutex underscore init. Now let's imagine here one situation here. There are two threads are there in a single process. There are two threads are there in a single process. Now, will you agree? These two threads are having a common data section. Now, can you tell me what may be the what is the data present in the data section? What data section contains? This is a C question. Can you tell me what the data section contains? Can I say static variables, external variables? Can I say global variables? Can I say global variables? Will you agree? Now, these two threads which are present in a single process, they can share this static array, global array, whatever it is. The problem is, if these two threads are trying to access the shared resource at a time, again we required, if these two threads are accessing the common resource at a time, again we required some synchronization concept. Please reply it yes or no. If multiple threads which are present in a single process, if multiple threads which are present in a single process, if they are accessing the common resource, there is a chance of data gets mixed, data gets corrupted. So we required thread synchronization. Yes or no? We required thread synchronization. Yes or no? So how the thread synchronization is achieved? Thread synchronization is achieved using the concept called mutex, mutual exclusive event. Thread synchronization is achieved through the concept called mutex, mutual exclusive event. So these are, just a minute. So these are the functions. So these are the functions involved in the, so these are the functions pthread underscore mutex underscore init, pthread underscore mutex underscore destroy, pthread underscore mutex underscore lock, pthread underscore mutex underscore try lock, pthread underscore mutex underscore unlock. So these are the functions involved in the synchronization between, these are the functions involved in the mutex concept. So will you agree? In this 10 functions, around 4 functions or 5 functions are related to mutex only. 4 functions or 5 functions related to mutex only. Yesterday, can anybody tell me which are the functions we used it? We didn't discuss detail, but we used it. Yesterday, can you tell me which are the functions we used it? When I say 2 functions yesterday we used in yesterday's discussion, one is pthread underscore create and another one is a pthread underscore self. So today we need to continue with that. Today we need to continue with that. Observe here. Observe this program. Now, just a minute. Can anybody tell me in this program how many function definitions are there? Can anybody tell me in this program how many function definitions are there? Two. Well, in this program, two function definitions are there. One is thread1 function and another one is main function. Can you tell me, as a C programmer, all of you know which function started executing first? Which function started executing first? Main. Now, what we are doing here in the main? What we are doing here in the main? What we are doing here in the main? Can I say we are creating the thread? We are creating the thread. Huh? Now, can I say this is a very important argument in this function? Which function you are registering as a thread? That function address you need to pass. Again, in this argument is very important argument. This argument is very important argument. That argument indicates which function you want to make it as a thread. That function you need to register it, pass the address. I hope all of you might have remembered how an array name represents a base address. Similarly, function name represents a base address. Listen. So now whenever you are designing any thread function, the syntax is return type should be void pointer, argument also should be void pointer. One important point, whenever you are designing a function for a thread, whenever you are designing a function for a thread, that function return type should be a void pointer and argument should be a void pointer. Now, can anybody tell me, whenever we are designing a ISR for signal, what is the prototype of that ISR? Try to recollect the concept of signals. Whenever we are designing any function for ISR in a signal concept, that function return type is void, return type is what, and argument is what? Can I say that function return type is void, ISR function argument is int. Now can you tell me what is this int n holds? Because of what signal the ISR is executing? Because of what signal the ISR is executing? That signal number, again, because of what signal that ISR is executing, that signal number. If you accept this statement, type 2 in the chat box. If you accept this statement, type 2 in the chat box. So, whenever you are designing any function for thread, whenever you are designing any function, whenever you are designing any function, whenever you are designing any function for thread, you need to make sure that that function return type should be, whenever you are designing any function for thread, you need to make sure that the function return type will be void star B9C2. There is a lots of difference between void and void star. Asal. So it should return the void pointer takes a void point. Hmm? Now my question is, when I'm compiling this program, how to compile it? Is it a normal or we need to use some anything extra here? Hyphen pthread. Now can you tell me why we need to use hyphen pthread here? Can anybody tell me why we need to use hyphen pthread? Answer is, these function definitions are present in one library. That library default linker will not link it. Again, whatever the thread functions we are discussing, those thread functions are present in a separate library. That those functions are present in the separate library. That library linker is not linking it. That library linker is not linking it. So that is the reason we need to use hyphen pthread. Hmm? Now, what is the return type of the next discussion is what is the return type of the pthread underscore create? What is the return type of the pthread underscore create? It is an integer. Yes, sir. Pthread underscore create integer. All of you see here, pthread underscore create function returns 0 on success or a positive error number on error. All of you copy this. Pthread underscore create function returns 0 on success. Upon success, it will return 0. On error, it will return a positive number, error number. I hope at this stage return type is clear. If it is clear, type C. Pthread underscore create returns one integer. Upon success, it returns 0. Upon failure, it will return some error number. One thing I need to tell you, interview point of view, theoretical concept of the threads is important. Most of the interviews, even though in an offline mode also, previously before lockdown, before this corona, most of the interviews when it comes to the threads, they will ask you the theory concept. So this theoretical points you should be very clear. Return type is integer. And what is the third argument? Can you tell me what is the third argument? Which function you are making as a thread? That function. Which function you are making as a thread? That function. Now let's discuss the fourth argument here. Let's discuss the fourth argument. What is the data type of the fourth argument? What is the data type of the fourth argument? What is the data type of the fourth argument? Void star means you can pass any data type address. Fourth argument is a void star. Will you agree? You can pass any data type address. So observe what is the significance of the fourth argument is I'm passing one string here. What is the significance of the fourth argument is I'm passing one string here. Printf in thread underscore 1 percentile s slash n comma char star p. Observe hyphen p thread. Now tell me, in a thread 1, I'll open one more terminal to show you the output. cd linux threads vi t1.c vi t1.c. Now observe this scenario very carefully. Now here, when main thread is creating the subthread, it is passing one information. String name represents, can anybody tell me, string name represents base address. Yes, sir. Now you are passing this hello world base address. Can I say this address is now available in this P? This address is now available in the P. That is the reason in this thread, if you print the P, you got hello world. I'm talking about which argument here? I'm talking about which argument? Fourth argument. What is the significance of fourth argument? Listen very carefully. When main thread, while creating the subthread, if it wants to pass some default information to the thread, they can pass via fourth argument. Again, if main thread, I'll write it that it will be good. If main thread, when it is creating subthread at that time, if he wants to pass some information to that subthread, they can pass main thread can pass using fourth argument. When main thread is creating the subthread, at that time, if he wants to pass some information to the subthread, main thread can pass using the fourth argument. All of you are observing that fourth argument. Now, can I pass address of one structure? Can I pass here address of one structure? Yes. If I am passing the address of a structure, here explicitly you need to typecast it. You need to use arrow operator. Can I pass address of integer? Can I pass address of integer? Yes. If you are passing the address of integer here, anyway you are catching with a void pointer, explicitly you need to typecast. Explicitly you need to typecast. Yeah. You need to typecast like this. Star int star pick d8f1. That is a wrong explicit typecasting when you are fetching it. Is it clear? So now P acts as which pointer? Basically P is a void pointer. P acts as integer pointer and then dereferencing. I hope with this example, you got the significance of the fourth argument. So when main thread is creating the subthread, at that time of creation, if he wants to pass some default information to the subthread, it can pass via this fourth argument. I hope all of you got the return type. I hope all of you got the third argument significance. I hope all of you got the fourth argument significance. Is it? Is it? Now, let's talk about the first argument. Here, main thread is getting the subthread ID. First argument significance is main thread will get the ID of the subthread. Now, can anybody tell me what is the fork returns in a parent? Can anybody tell me what is the fork returns in a parent? Child ID. Here also the same thing. When main thread is creating the subthread, if main thread wants to know the subthread ID, they can catch in this. I'll show you with an example so that it will be clear. Just a minute. Printer in main thread T1 is equals to percentile LU. T1. Now will you agree this T1 and this pthread underscore self should be the same? Will you agree that T1 and that pthread underscore self both should be the same? That T1 and the pthread underscore self both should be the same. Please try to respond it. If main thread wants to know the subthread ID, they can get it that thread ID via this argument. They can get the ID via this argument. Let me compile the code. Let me run the code. See, in main thread, what is the T1 is holding? 264. Is it the subthread ID? In main thread, the T1 is holding 264. In the main thread, the T1 is holding the 264. Is it the subthread ID? Is it the subthread ID? Answer is yes. Just a minute. In a main thread, this T1 holds this thread ID. Both are same here. Getting the point? Both are same. So I hope all of you got the significance of first argument. What is the return type? What is the third argument? What is the fourth argument? Is it? Yes or no? I hope all of you got the written type and the first argument, third argument, and fourth argument. And no need to worry about the second argument. Just make it as a zero. If you want to get more information about the second argument, you can go through the material or you can go through the man page. So for the time being, no need to worry about the second argument. Hmm? One more important point I need to tell you here. One more important point I need to tell you here. Just give me 1 minute of time. Just I'll create a separate program t1.c, t2.c, t2.c. Just I'll uncomment this. While one printf in thread underscore one in thread underscore one. But I'm not putting while one here. Observe, in a main function, I'm not putting any while one. In main function, I'm not putting any while one. But in a thread function, I am putting the while one. Observe here. In main function, I am not putting any while one. In a thread function, I am putting the while one. Again, in main function, I am not putting any while one. But in a thread function, I am putting the while one. All of this observation is clear. The changes which I made in the source code, is it clear? In the main function, I am not putting any while one, but in a sub function, I am putting the while one. Now observe, let me compile the code. Let me compile the code. Let me compile the code. cc hyphen pthread. Let me run the code. Now what happened? Now what happened? Is the subthread while one is executing or not? Now can you tell me, subthread while one is executing or not? No. A very simple concept, try to understand. When you close main app, can I say sub apps are going to be, sub processes, sub threads are going to be closed? Now suppose in this application, I might have used multiple tabs. Can you tell me, when I close this app, all the tabs are going to be closed? Similarly, here also one condition is, when subthread wants to execute, main thread should be alive. Again, when subthreads wants to execute, main thread should be alive. Because here main thread is not alive. In main thread, I am not written any while one. Even though subthread is created, main thread is terminating. That is the reason the subthreads will not execute. Subthread will not execute. If this observation is clear, type C in the chat box. There are few solutions are there to achieve this. One is, you can use pthread underscore exit function. One is you can use pthread underscore exit function. Now observe. Now tell me. In a main, if I use pthread underscore exit, even though main thread is exited, the subthread continues. Even though in a main thread is exited, subthread gets continue its process. Is it clear? So one thing, if you want to terminate the main thread, suppose this is the main thread, suppose this is the subthread, one is the main thread and another one is the subthread. If subthread wants to execute, one is main thread should be in a while one. Second is in a main thread you can use pthread underscore exit function. Second, you can use pthread underscore exit function. So if you use pthread underscore exit function, what happens? Can you tell me what happening? If you use pthread underscore exit in a main thread, what happening here? Can you tell me? If you use pthread underscore exit in a main, even though main thread is exited, can I say subthread is continuing it? Even though main thread is exited, subthread is continuing it. Even though main thread is exited, subthread is continuing it. If this observation is clear, type 2 in the chat box. If this observation is clear, type 2 in the chat box. Again, I need to tell you B8F1. Here there is no concept of orphan and zombies because these are in a single process only. So in one process only all these things are happening. There is no orphan concept, there is no zombie concept in this situation. So what is the use of pthread underscore exit? To exit from the thread. Pthread underscore exit. What is the use of the pthread underscore exit? It is used to exit from the thread. So in a main, if I use pthread underscore exit, in the main, if I use pthread underscore exit, then what happens? Even though subthreads are there, even though main thread is exited, the subthreads continue its process. Subthreads continue its work. So why I am passing 0? We'll see that. Why I am passing 0? We'll see that. Next is, next function we need to discuss here, that is next function we need to discuss here, pthread underscore join. Joining with a terminated thread. Pthread underscore join. Joining with the terminated thread. Noted on this, pthread underscore join, joining with terminated thread. The pthread underscore join function waits for a thread identified by thread to terminate. Can I say this is blocking function? Can I say this is blocking function? It will block this thread it will block the thread till this thread gets completed. Again, pthread underscore join is a blocking function. It will block the thread who is calling this function until the thread which you passed as a first argument, until it terminates. It will be more clear if I show you with one example program. CP T2.c, T3.c, VI T3.c. Observe here. Now, can you tell me, by seeing these lines, how much time thread 1 need to complete its work? Can you tell me how much time thread 1 required to complete its work? Can I say 20 seconds? Now observe, printf in main thread before pthread underscore join. Pthread underscore join, first argument is thread, second argument is address of pointer. Printf in main after join percentile s slash n comma. I'll give the explanation. Just let me finish this program. Let me show you the output. I hope all of you know this argument significance. Now this argument significance is this one. You'll see this. Now can I say this function will block till this thread gets completed? This function will block till the T1 thread gets completed. So can you tell me how much of time this thread required to complete its task? How much of time the thread 1 required to complete its task? 20 seconds. Now can I say this line is going to be printed. This line is going to be printed after 20 seconds only. This line is going to be printed after 20 seconds only. And at the time of exit, it is sending one address. At the time of exit, it is sending one address. That address is available in this pointer. At the time of exit, that thread 1 is sending one address. That address is present in this P. That address is present in that P. Now can anybody tell me what is the meaning of double star? What is the meaning of double star? Can I say address of a pointer you need to pass? Double star means you are catching with a double star means we need to pass address of a pointer. I don't know you remembered or not. There are two cases we can catch with a double star. One case is when we are passing the address of a pointer. Second case is when we are passing the array of pointers, base address. I don't know you remembered or not. There are two cases we can catch with a double pointer. Case number one, when we are passing the address of a pointer, we need to catch with a double pointer. Case number two, when we are passing the array, in that array the elements are pointers, array base address, array of pointers. Then also you need to catch with a double point. Now here, can you tell me what I am passing, to this pthread underscore join? Can you tell me what I am passing to that pthread underscore join? Second argument. Can I say address of a pointer? Address of a pointer. Now can you tell me what is this p holds? Can I say this string base address it holds? That string base address it holds. That string base address it holds. Hmm? Now can I say this is it will block until this thread gets completed. Let me compile the code and let me show you the output. Let me compile the code. Cc hyphen pthread dot slash a dot out. Can I say in main thread before join is printed? After join is not printed. Can I say in a main thread pthread underscore join is blocking there? In a main thread pthread underscore join is blocking there. In a thread sleep function is blocking. When the subthread is completed, main thread start continued its work. When the subthread is completed, the main thread that blocking it unblocks. All of you are observing this. So try to copy this program. Try to copy this program, example program. So will you agree there is some relation between the exit and join? There is some relation between the pthread underscore exit and pthread underscore join. Will you agree? Okay. Take a 2 minutes of time. Take a 2 minutes of time. All of you copy this. If anything is there, please let me know. I'll set a line number. Please take a 2 minutes of time. I will be back. If anything is there, please let me know. All of you copied? So I hope the significance of pthread underscore join and pthread underscore exit, you might have got it. Now, using this concept, I'm going to create one scenario. Observe the situation is like this. So this is one main program. This is one main program. This is one program. That is one program. This is the main function. This is a thread, one thread, and this is another thread. This is the main. And this is one thread. This is another thread. Here also the same thing. One thread, another thread, and the main. One thread, another thread, and the main. Suppose this is the P1.c. Suppose this is the P2.c. My job is, we need to achieve the full duplex communication. We need to achieve the full duplex communication. This is the F1 FIFO. This thread need to write. This thread need to read. This is the F2 FIFO. This thread need to write. And this thread need to read. And here, from the keyboard, we need to scan it. Here on the screen, we need to display it. Here from the keyboard, we need to scan it. Now here on the screen, we need to display it. All of you copy. This is one thread and this is another thread. This is the main thread. This is one thread and this is another thread. And this is the main thread. All of you copy this situation. These are the F1 and F2 are FIFOs. F1 and F2 are FIFOs. F1 and F2 are two FIFOs. Now tell me, here we are achieving the full duplex communication between how many processes? Here we are achieving the full duplex communication between how many processes? Answer is two processes. In those two processes, what is this thread job? Can you tell me what is the job of this thread? What is the job of this lightweight process? What is the job of this lightweight process? Can I say the job of this lightweight process, this thread is to scan the data from the keyboard and write it into the first FIFO. Write it into the first FIFO. The job of this thread is read the data from the second FIFO, put it into screen, put it into the screen. Now can you tell me what is the job of this thread? Can you tell me what is the job of that thread? Read the data from. What is the job of this thread? Will you agree? Read the data from. Read the data from F1 FIFO, print it on, read the data from F1 FIFO and print it on and print it on the screen. What is the job of this thread? What is the job of this thread? Scan the data from scan the data from scan the data from keyboard, write it into F2 FIFO. What is the job of this main threads? What is the job of this main threads? What is the job of this main threads? They need to create this subthreads and they need to exit. Here I need to use pthread underscore exit. All of you are getting the point? Here I need to use pthread underscore exit. I'm going to create this scenario here. I'm going to create this scenario here. I hope all of you might have remembered the functions involved in this IPC mechanism. The functions involved in this IPC mechanism FIFO, MK FIFO, MK FIFO, MK FIFO, open, read and write. MK FIFO, open, read and write. MK FIFO, open, read and write. Okay. Now observe, I'm going to write the code for this entire scenario. Now I'm going to write a code for this entire scenario. So I'm going to create two programs. What are those? P1.c. Hash include header.h, void star thread underscore 1 void star p, void star thread underscore 2 void star p, void main pthread underscore t t1 comma t2. MK FIFO F1 0664, MK FIFO F2 comma 0664. After that, pthread underscore create. First argument is address of t1, 0, thread underscore 1 and 0. Pthread underscore create address of t2, 0, thread underscore 2 comma 0. After that, pthread underscore exit. Now can you tell me why I am using pthread underscore exit? Can you tell me why I am using pthread underscore exit? Why I am using in a main thread pthread underscore exit? Even though this thread is completed, this thread is terminated, can I say those two threads will continue their job? Will you agree? Why I'm using in the pthread underscore exit? Because even though these two threads, even though main thread is completed, when I say those two threads will continue its job. Now can you tell me what is the first I'm doing? What I'm doing here? I'm creating the F1 FIFO. I'm creating F2 FIFO. I'm creating the two threads and I'm terminating it. Main is terminating. Please respond it. Getting the points or not? Please respond it. Are you getting the points or not? Okay. Now what is this thread one need to do? Scan the data from user and put it into F1 FIFO. So int fd is equals to open F1 FIFO O underscore RDWR. Actually, here I need to open only for writing purpose because it need to put the data into F1 writing purpose. Safe side I am using read also so that this open will not block. I hope you might have know that. I hope you might have remembered about the FIFO. So I am opening both ends even though I am not going to read anything. Even though I am not going to read anything. Even though I am not going to read anything. I am opening in both ends. Okay. After that, just a minute. After that, put a while one. In this while one, what we need to do? In this while one, what we need to do? Scanf percentile s comma s and write fd s strlen of s plus 1. Observe this diagram. As per this diagram, that is working or not, let me know. Observe this. His thread job is scan the data from the keyboard, put it into F1 FIFO, scan the data from the keyboard, put it into F1 FIFO. Is it working? Is it the statements, whatever I written, is it clear? Okay. What now? Now I'm going to write this thread. This thread job? What this thread job? Read the data from F2, print it on the. Read the data from F2, print it on the screen. Read data from F2 FIFO and print on the screen S of 20. Int fd is equals to. Now can you tell me what is the storage type of this S and this fd? Storage type. Storage type auto. Where the auto variables are present? Where that auto variables are present? Can I say that thread stack frame? That thread stack frame O underscore RDWR while one read fd s size of s, printer data is equals to percentile s slash n comma s. So this thread 2 job is this thread 2 job is, observe this thread 2 job is read the data from the FIFO and print it on the screen. Now we'll agree these two will execute concurrently. Thread 1 and thread 2 will execute concurrently. Now this program is done. So cc p1.c hyphen o hyphen p thread hyphen o p1. Observe how I compiled it. All of you copy that command. All of you copy that command. All of you copy that command. Okay. Now cp p1.c p2.c vi p2.c. In the p2.c, what is the first thread need to do? In a p2.c, what is the first thread need to do? Open F1 for reading purpose and print it on the screen. First thread need to open F1 for reading purpose and print it on the screen. Can I say here read and print? Here read and print. Read system call fd and second argument is s, third argument is size of s, and print it. Printf data is equals to percentile s slash n comma s. Read and print. What is the thread 2 job here? Can you tell me what is the thread 2 job? Scan and write it into thread 2 job is scanf percentile s comma s and write fd comma s comma strlenfs plus 1. So this is also done. cc p2.c hyphen pthread hyphen o p2. So can I say p1 p2, two executable files are ready with us now. p1 p2, two executable files are ready. p1 and p2, two executable files are ready with us. So now observe. Now observe. So dot slash p1 dot slash p2. Now can you tell me where I need to type the data? In which terminal I need to type the data? In any terminal you can type. Suppose if I type it here, I say that is received. If I type it here, that is received. If I type it here, that is received. Can I say here I created two threads. One thread is Scanning and writing, another thread is reading and printing. Both are concurrently executing. Here also the same thing. Both are concurrently executing. There also the same thing. So this is how we are achieving the full duplex communication between the two processes, but multi-threading concept, but using multi-threading concept, Is it clear? So what is the main thread is doing? Can you once again tell me? What is the main thread is doing in line number? Just a minute. I'll set the line number. What is the main thread is doing here? What is the main thread is doing here? Line number 29, creating F1. Line number 30, creating F2. Line number 31, creating a thread. Line number 32, creating another thread. Line number 34, this is terminating. That is terminating. Is it clear? Now, if you don't write this, will you agree you need to write while one there? If you don't write that, will you agree you need to write while one there? If you don't write while one and if you don't write this, what happens? If you don't write while one and if you don't write this, what happens? Can I say subthreads will not continue its job? Will you agree the subthreads will not continue its job? Total process gets terminated. Is it clear? Now my question is very simple question. If I declare a global array, all these three threads can access. Thread 1, thread 2, main can access because it is present in a data section. There is no separate, that is a common. This array, this memory is common for thread 1, thread underscore 2 and main, so that they can communicate between each other. Again, so that they can communicate between each other. So that they can communicate between each other. But the problem here is, because it is a common, there is a chance of data gets mixed. Before thread 1, suppose thread 1 is writing into this array, thread 2 is reading from this array. So before thread 1 writes, thread 2 reads. Can I say it will read old data? Listen, before thread 1 writes the data into this array, if thread 2 reads, can I say it will get the old data? So here, will you agree synchronization required P2, BE9, P2, getting the point? At the same time, you cannot. If at the same time you want that like the data is going to be lost. Now, I don't know you remembered or not, in a semaphore, alternative copy we discussed. At the same time, both are accessing, but alternatively. So here, we need some synchronization method to solve this problem. We need some synchronization method to solve this problem. So that's what thread synchronization can be achieved using. Thread synchronization is achieved using mutex. Thread synchronization is achieved using the concept called mutex. So that we'll discuss in a tomorrow's session. Is it clear? And one more important notice is tomorrow Only one class or two classes required. Saturday I'm going to wind up this. Notice is next to two sessions at 2 o'clock. BE9 people, they may have the class at 2 o'clock, right? BE9 people, they may have the class at 2 o'clock. Is it? So for 2 o'clock class is going to be shifted tomorrow onwards 7:30. 2 o'clock class tomorrow onwards, they are going to be shifted to 7:30. Is it clear? That BE9, whatever the 8051 SPI protocol is there, or whatever the ARM, it is a hybrid only. Hybrid. Those who are interested, they can come. Is it clear? So next two sessions, my two sessions will be tomorrow and after tomorrow, 2 o'clock. I'll upload in the LMS. I'll change the things in the LMS. And those who are having 2 o'clock class, their timings is morning 7:30. It is in a 8051 BE8 and 9 and 10. It is in a hybrid mode. It's clear? So tomorrow we'll meet at 2 o'clock. My class is total online. B8F1 is asking one question, sir. In T3.c, who is assigning the buy address? How it is? Okay. So one question came. Just L. Now here everything is a thread manager will be there. Everything is a thread manager will be there. Is this notice is clear? Type C in the chat box, all of you. Tomorrow my session will be 2 o'clock total online. Those who are having a 2 o'clock session, for them 7:30 morning. Okay. Now observe, this is used to send and this is used to receive. All of you are getting the point? So when subthread wants to send something to the main thread, they can send via exit. When subthread wants to send something to the main thread, they can send via when subthread wants to send to the main thread something, they can send via this. You got the point? Getting? B8F1. This string address is going to be stored into this P. Okay. Thank you very much. Tomorrow 2 o'clock we'll meet.